So, I am Mitra Shini from SMK Buntung. So today I will be your duos here. Um, so let's get started. Okay. So today we will be looking at chapter 5, which is waves. Um, so now let's look at our objectives today. First of all, I would like to ask all of you to go a few questions as we go through this class. So the first of all, we will be understanding our is our 5.6 is about. Please tell your answers in the chat box. Okay, so 5.6 is about interference of wave. We will be recalling back keywords, definition, and concepts. Okay, thank you so much. We will be today recalling back keywords, definition, and concepts, and then we will look at a structure question, which consists of a 1 mark definition question and a 4 marks application or physics concept question. And finally, we will be looking at an essay question, a 10 mark suggestion question, along with our answering techniques. So let's move on. First of all, let's look at terms that's given here. First, we have principles of superposition of wave. So here they have stated that when two waves overlap, the resultant displacement is the sum of individual displacements of the two waves. So this might look a bit confusing. Well, what they're trying to say is the resultant displacement, which is the result of combination of two waves, is the sum of individual waves, which means these two waves, when they combine, when they sum up, we get the resultant displacement either in a positive value, or we call it as constructive, or in a negative value, or we can also call it as destructive. So, our first definition will be constructive interference. But before that, what is exactly interference of wave? So, superposition of two or more waves from a coherent source of wave. This is the definition of interference of wave that you should remember so that you can write it in your exam when it's asked. Okay, so can someone tell me what is the keyword in this definition of interference of wave? Please tell me what is the keyword of interference of wave? Okay, so the keyword in this definition is superposition. Okay, and coherent source. These two words must be present when you're writing the definition. And then the third one, we have coherent waves. This term, I will come back to it later. So before that, let's look at the types of interference. The first one, we have constructive interference. There are two types of interference that we would have learned, which are constructive and destructive. So what is exactly constructive interference? It is when two crests or two troughs are in superposition to produce maximum amplitude, which means um, two crests. Crest is usually the upper part of a wave and the trough is the lower part of the wave. So when two crests or two trough are in superposition, that means when these two waves coincide or in interference, they combine to form a maximum amplitude. You can see here it's 2A. A and A, we get 2A. When it comes to trough, it's in negative value, so it will be negative 2A. But after the superposition, it will be back to its normal position. Okay, so before it's moving, and then it forms a maximum amplitude, and finally it goes back to its normal position. So over here, we have to focus on this two crest, two trough are in superposition to produce maximum amplitude. This is our keyword. And then the next one, we have uh, we have destructive interference. What is destructive interference? Just by hearing the word destructive, we can know that it is destroying something. Two things combined together so that it gets destroyed or form a smaller value than the initial one. So destructive interference occurs when a crest and a trough are in superposition to produce combined zero amplitude. That means when a crest and a trough, which has an amplitude value of A and negative A, when it combines, it produces a straight line. Straight line represents zero amplitude produced. And after the superposition, it goes back to its normal position. So, is there any questions? Are you all okay with my explanation? Please respond. Okay, let's move on. Now, we are looking at the definitions and differences between coherent source and coherent wave. These two terms are usually asked in exams, and I think this is something we have to focus on. So, we have two different meanings over here, definitions over here. Can anyone tell me which one is the definition for coherent wave and which one is the definition for coherent source? Please respond to my question in the chat box. Which one is coherent wave and which one is coherent source? Okay, thank you so much. Yes, it's correct. The first one, which one we are looking at here, is the definition of coherent wave. So, what are exactly coherent waves? Coherent waves are waves that have same frequency, same wavelength, and same phase difference. Meanwhile, coherent sources means sources that produce waves which have same frequency, same wavelength, and same phase difference. So, after looking at these two definitions, you can feel like something is kind of similar and something is a bit different. So, what is the difference and what is the similarity? So in waves, we have the word waves over here. Okay, yeah, waves that have frequency, same wavelength, and same phase difference. But in the sources, we have the word sources that produce waves. As we all know, sources is something that produces an outcome. So in this case, coherent sources are sources that produce coherent waves. So when we are writing the definition, the word sources that produce must be there if the question is asking to state the definition of coherent sources. And also, one more thing that I would like to emphasize is the keyword same. When we are writing the definition, the keyword same must present 3 times. You can't only write it only one time, which means you can't only write waves that have same frequency, wavelength, and phase difference is wrong. You have to mention the word same 3 times to get the max to get marks. Okay. Moving on. Now let's look at this diagram. What can you see from this diagram? We can see the interference of wave. So, what do you call points that that are in constructive interference. My question is, what are the name of the points where constructive interference occurs? Guys, please answer. What is the name of the points where constructive interference occur? If anyone know. Okay, it's all right. Um, so there's another name for the points where constructive interference occur, which is the antinodal point. You can see it over here. They've stated it. Locations along the medium where constructive interference continually occurs are known as antinodes. We can call it as antinodal point or antinodes. Meanwhile, the points where destructive interference continually occurs is nodal points or nodes. And the line that joins all the antinodal points are known as antinode line. And the line that connects all the nodal points is known as the nodal line. Okay, are you all clear? So how do we identify constructive and destructive interference? As we saw just now already, constructive interference is when a crest and another crest, or a trough and another trough are in superposition. So here they've said it's an antinode line. So let's see if it's really true. So here we have a dotted line which represents the trough, and the crest, which is the straight line, is our constructive interference also. So here, there's two trough, and there's uh, interference. So there's constructive interference occurring. And the point, all these points you can see here, is a trough. Both of them are a trough. And all the points are the points where constructive interference occur. And we can also look at the destructive interference. Here, it's a trough. I'm sorry, it's a trough, and this one is another crest. Okay, so this line is, you can see this line is a trough, and this line is a crest. So the point is showing the destructive interference, and this line shows the nodal line. Okay, moving on, we also have our formula for this interference of wave. You can see it over here. Lambda equals to AX over D, where lambda is the wavelength, A is the separation between two sources, which means the distance between these two sources of wave. Okay, and then the X is the separation between two consecutive antinodal or nodal lines. What does that mean? Separation between two consecutive antinodal or nodal lines is, let's for an example, let's take the antinode line. So the distance from here to here is the 1x. And if we go for the nodal line, we can consider this to this, the first nodal to the next nodal, or the first antinodal to the next antinodal is our x. And finally, we have the d, which is the distance from the source to the position where x is measured. Let's say we measure our x over here and our a is over here. So the d will be the distance between our a measured and our x measured. Okay, is everyone clear? Okay, let's move on. Now we will be looking at our, okay, we will be moving on to our question today. Okay, so the first question that we are having is, this question is from a structure question, as I said already. It's a 1 mark definition question and another 4 marks physics concept question. So I took this question from this trial SPM, Perlis, from Perlis trial SPM 2024. So let's look at the question now. Okay, first, before always, you have to remember before answering the question, you have to identify the keywords. So let's read this question first. Diagram 9.1 shows two men are fishing by a lake. Both of them use same length of fishing rods. Okay, so same length of fishing rods. When both fishing rods are thrown simultaneously, simultaneously means thrown at the same time, not at a different time, but at the same time into the water. A set of water wave pattern is formed. You can see here the water wave pattern that is formed. So, from this picture, we can analyze one thing, which is bright fringes usually represent constructive interference. Meanwhile, dark fringes usually represent destructive interference. So over here you can see there's bright and then dark fringes and then bright and then another dark. So that this represents constructive and destructive interference. So let's go look at the question. First, what is meant by coherent source? So in this case, they are asking about coherent sources. Can anyone give me the definition of coherent sources? As we already saw the definition for it. Please, can anyone tell me the definition of coherent sources? Okay, we have one question from Chu Zi Xuan. Sources that produce waves that have same frequency wavelength. So just now I said that we have to mention the word same three times. We can't only mention it once. So if you're going to give your answer, you have to state same frequency, same wavelength, and you also left out one term, which is same phase difference. Okay, thank you for trying. Um, anyone else? Anyone else want to give your answer? Okay, it's all right. Let's look at our answer now. Okay, sources that produce waves that have same frequency, same wavelength, and same phase difference. You see the keyword over here, same frequency, same wavelength, and same phase difference, and also the word sources that produce. Let's say if they ask about waves, coherent waves, then you can write only waves that have same frequency, same wavelength, and same phase difference. So how exactly are we going to remember all these two definition? So a tip from me is you can remember either the definition of coherent wave or the definition of coherent sources. So when they ask in exam, you can choose either one and write it in your exam, but it depends. Let's say you remember the definition of coherent wave, and in the exam, they are asking you for the definition of coherent sources, just like here. Then when you're writing your answer, you have to add these three words, sources that produce. So then you will get your full marks because they're asking about coherent sources and not waves. So you have to be very careful when you're answering this question. Okay, so the next question. Okay, is everyone clear? Am I too fast? Please respond. Am I too fast? If I'm too fast, please tell me. Is everyone clear? Okay, 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 thank you. So the part B question, explain how constructive and destructive interference are formed. Over here, the keywords would be how constructive and destructive interferences are formed, and it is a 4 marks question, which means we should have 4 points for 4 marks. Okay, so in this case, they are only asking about how constructive and destructive are happening. They didn't ask about how these bright and dark fringes are formed. If they ask about how dark and bright fringes are formed, we can talk about these physics concept there where they talk about the light diverging and converging, but in this case we can just talk about this only the definition of constructive and destructive. So our answer is this. This will be our answer. So the first point goes for giving the definition for interference. So interference occurs when there's a superposition between two waves or more from coherent source of wave. Here, over here, we will get 1 mark. Okay, and then the next mark goes for the definition of constructive interference. Because in this question, they're asking about how it occurs, how constructive and destructive interferences are formed. So the second marks we will get when we state the definition of constructive interference um, between two crests. And okay, so constructive interference occur when two crests are in superposition to produce maximum amplitude. Okay, here we will get 1 mark. And then the third mark, we also talk about constructive interference, but in this case, we are talking about two trough. Okay, just now we talked about two crests, and the next one, right now, we are talking about two trough to produce maximum amplitude. Okay, it's the same, but since there are two different components, we are separating it. Um, we are stating these two separate definitions. So far we have gotten 3 marks, and finally we have to state the definition of destructive interference. So what is destructive interference? Destructive interference occur when a crest and a trough are in superposition to produce combined zero amplitude. When a crest and a trough are in superposition to produce combined zero amplitude. So overall, we get 4 marks. Okay, is everyone clear? Any questions in this part? Okay, so let's move on. Now, we are looking at this one essay question, which is a 10-mark question. Okay, first, let's read through this question first. Diagram 9.2 shows the seating arrangement of an indoor hall. So you can see here we have two loudspeakers, a stage, and seats for the audience. And this table 9 shows 4 types of sound system to be used in the indoor hall. Okay, before we look at this table, let's look at the question first. Based on table 9, you are required to determine the sound system design that could be used in producing a good and more obvious sound quality during the event takes place. Explain each suitability and determine the most suitable sound system to be used. Give reasons for your choice. Okay, from this question, we can find out keywords. So the first keyword we are going to look at is you are required to determine. Uh, okay, you are required to determine the sound system that could be used in producing a good and more obvious sound quality, which means we need to hear perfect sound without any interruption or breaking and so on. And we have to explain each suitability for our choice, and we have to determine the most suitable sound system. We have to state overall which sound system we are going for. So in this case, let's analyze the table first. Now, we have already analyzed these keywords in the question. Now we are going to analyze the table where they have given these characteristic 1, characteristic 2, 3, and 4, and they have 4 types. Okay, we have position of loudspeakers, distance between two loudspeakers, material to cover the wall, and position of microphone. So, um, there is this one difficulties that we can face when we're answering this question. We might go blank when we're looking at this table. We will be like, oh my god, I don't know what to do right now, because you don't know which one to choose. There's four choices and four characteristics. You have to choose one from it. Um, and you have to determine the reason also. So to avoid this situation, to avoid this nervousness or unable to answer this question, usually what I would advise you guys to do is pick one characteristic that you are very confident with. So out of these four characteristics, pick one and choose the specification first. So if I were in that place, I would go for material to cover the wall. There are two choices, which are softboard and hardwood. So from my own knowledge, I would say I would go for softboard because softboard tend to absorb sound and prevents echo. And we have already learned this back in our Form 2 science syllabus. So if me, I would look at this characteristic materials cover the wall, and I would pick softboard. So in that case, only two types of sound system has the characteristic of softboard, which are W and Y. So automatically, the other two characteristics are rejected because both of them use hardwood. Because usually hardwood tend to reflect sound, and we don't want the sound to reflect, as we only want to produce a good and more obvious sound quality. Okay, so we have already chosen one specification. Now we look at the others. Position of loudspeaker. Now we compare between these two because we have to choose only one sound system. So we compare first position of loudspeakers. W there is high, Y high, and distance between two loudspeakers. W it has small distance, meanwhile Y has large distance. Position of microphone behind the speakers. So both have the same characteristic. So since position of loudspeaker and position of microphone has the same specification, we are focusing on the distance right now. Small distance or large distance. Okay, in this case, we have to use our common knowledge. Okay, imagine there are two speakers very near to each other. Okay, and the area covered is very small. Okay, this area covered is very small, and there's another place where we have large distance between two loudspeakers, and the area covered is huge. Okay, if we keep it very close to each other, possibilities are there that where only a few audience can hear the sound produced, and there might also occur this annoying sound of this annoying sound that you can hear. So based on my knowledge, I would say I would go for the large distance between two loudspeakers, and that goes for Y. So finally I choose sound system Y. Okay, so we have to answer this question in table form, as we all know. Okay, there are two types to answer this question. First, we have this two column and the three column. In two column, we only have suggestion and reason, but in the three column, we have characteristic, specification, and reason. Okay, in this two column, we combine our specification and characteristic together and state our reason over here. So it's easier for us when we finally make our choice at the bottom. Okay, but in this three column technique, we will separate everything. Position of loudspeaker, we separate it, and then specification, and then reason. So in my opinion, I always go for this three column answering type, because I think it's easier for my teacher to mark this my answer, because they are looking at our characteristic, specification, and our reason. we will only give the answers very short over here. But in this case, in this two-column case, our answers are a bit too long. So I don't really prefer this, but for you guys, it depends on how your teachers emphasize you guys to write it. Some teachers emphasize on doing it on in two-column. Some would say three-column. So it depends on your teacher. I don't force you guys to choose this one particular type. So let's look at our answer now. Okay, so this is our answer for our question just now. Position of loudspeakers should be high. Okay, and the reason is no obstacle for sound waves to travel. So when they are high, they are not in front of the audience, and since it's high, and the place in front, the surface in front of them is more empty, it's easier for the sound wave to travel. If it's lower and it's in front of the audience are blocking the sound waves to travel. So maybe it won't produce good quality of sound. So we get 1 marks for our specification and 1 marks for our reason. And then the next one, we have distance between two loudspeakers, which is large. So large distance between two loudspeakers, we will get more region of constructive interference. Just like how I said just now, um, when the distance between these two speakers are large, there will be more area covered by the sound region traveling. So when the area covered by the sound is more wider, then there will be more constructive interference occurring. Okay, if you don't understand what I'm talking about, okay, this is two speakers with large distance, and the area covered is this white. Okay, so in between over here, and okay, and another one, we have another one over here, small area covered. Okay, this is the small area covered, larger area covered. So larger area, we will have more constructive interference. Okay, but in smaller area, we only have a few constructive interference occurring. You can see here, there's 6 constructive, and here there's only 4. So when there's more constructive interference occurring, then the sound produced will be more clearer, more louder, and more better. Okay, so we have our second reason. And then our third characteristic is material to cover the wall. I've already said it should be soft board, and I also say soft board tend to absorb sound and reduce reflection. Okay. Yeah, and then the last one, we have position of microphone behind the speakers. The microphone should be behind the speakers so that sound does not overlap. Okay, is everyone clear with this answer? Is there any question? Is there any question? Okay, thank you. Um, okay, so now, just now I said that this question is a 10 marks question, right? But over here, we only have 8 marks, one, okay, one for the choice and one for the reason. So overall, over here, we only have 8 marks, okay? But we want 10 marks. Where is the 2 marks? Where is the remaining 2 marks? Can anyone tell me how to obtain these 2 marks? How do we get these full 10 marks? Please tell me, how do we get the remaining 2 marks, and overall we will get a 10 marks? How do we get it? Anyone, please tell me. Okay, correct. Conclude the characteristics. Yes, thank you so much. Yes, you have to write back your choice because just now we already um, saw this one requirement in the question. Okay, they say explain its suitability. So right now we have already explained all the suitabilities in the table, and we have to determine the most suitable sound system. We have to write back our choice along with our characteristics. Okay. And it's correct. Conclude. We have to conclude all the characteristics. So how do we conclude all the characteristics? Here, we have to state our choice first. The most suitable sound system is why? Because of all these, you have to conclude all the characteristics that we have stated here. High position of loudspeakers, large distance between the loudspeakers, soft board to cover the wall, and microphones behind the speakers. Okay, so when you state your choice, the most suitable sound system is what you get 1 mark over here, and when you state when you conclude all the characteristics, you get another mark over here. I would like to say that when you're writing your finals choice, you can't just write the most suitable sound system is why because of the characteristic above. That is wrong. You cannot write that. You have to mention back every single characteristic that you've stated in this table. Okay? And finally, you will get a total of 10 marks. Okay? Let's say we get all 8 marks over here, and you write your choice finally with your elaboration. You get 2 marks over here, 8 marks over here, and you get a total of 10 marks. Okay? Any questions? Any questions, guys? That's all for my session today. Is there any questions you guys would like to ask me? Um, please feel free. Don't hesitate. Please ask me if there's anything that you didn't understand. Okay, I think there are none. Um, okay, then I will be stop sharing. Okay. Uh, okay, so now in this chat box, we have shared this one Google form link. Can you all see this link? Okay. Uh, so please fill out the Google form and give our feedback. So that's all from me today. I hope whatever I shared today is beneficial and you guys have learned something or maybe refreshed back whatever we have learned last year in Form 4. Um, Thank you for joining my class. I think that's all from me. We will end this class here. Thank you very much.